A lot of non-Newtonian fluids are present in our daily lives, such as toothpaste, jelly, cheese, or even saliva are examples of this.
Initially, a non-Newtonian fluid doesn't behave like Newton predicts. It means they may not have a well-defined viscosity.
These substances are best studied through the rheological properties, which show the relationship between the applied stress on the substance and the strain rate under different flow conditions. This experiment consists in record the variation of the average speed of displacement of a mass completely immersed in a plastic measuring cylinder test tube with 500 microliters of the fluid. Consequently, it created a methodology to characterize the dilutant behavior of a non-Newtonian fluid composed by a solution of cornstarch and water, based on the principles of the rheology sciences. Setting up the system. 2 universal supports perpendicular to the table with a prominent hook parallel to the table on each of the supports. A nylon thread was passed through these hooks with a metal ball attached to one end, with a plastic measuring cylinder test tube containing the non-Newtonian fluid from which the ball would emerge. The other end was attached to a wooden platform where weights were placed. Experiment. Throughout 3 different concentrations of cornstarch in water, the test carried out consisted of measuring the time it took for the ball to reach the surface according to the change in the load that pulled it. With that data and the known height of the liquid, we can measure the average speed, then watch the impact of the applied tension in that value. As we increase the tension, the deformation of the liquid increases, applying resistance in the movement of the immersed body. To obtain the exact value of the tension applied in the liquid, we schematized and related the forces that influence the body immersed in the liquid as the following. We concluded that the forces that act in favor of the vertical displacement of the body immersed in the liquid are the buoyancy force and the wave force to the system. The force acting against the vertical motion of the body is wave force of the ball. The resultant force will accelerate the body and produce a movement variation through a time and velocity, assuming that displacement is equal to 24 centimeters. However, considering that this is a non-Newtonian fluid, the dilating fluid, in addition to the forces mentioned above, the movement will also produce a resistant force due to the deformation of the liquid after being subjected to shear stress. And finally, we can measure the value of the resistant force that will act in the body as a response to the applied shear stress, but we can measure the velocity of the body and see how this force impacts in the movement, considering that the speed of the body may decrease as we increase the F force. For all the results, we used the same parameters, only changing the fluid concentration. The wire used has a negligible mass, and we use bearings so that friction is also negligible. It created a system where it was possible to apply stress to the liquid in a controlled manner. So instead of having the shear stress as a result of the applied shear rate, we had the resulting velocity of a body immersed in the liquid. What we can say that is a response of the liquid deformation rate.